So yesterday we looked at qualitative data. Today we're going to be analyzing quantitative data. Now, to summarize quantitative data, we still can use a frequency distribution. But since we don't really have a natural categories, we divide the data into classes. Now, classes have to be intervals of equal width that cover all values in our set. So we set up a lower class limit and an upper class limit. So 0 to 4, 5 to 9, 10 to 14. The class width is the difference between each class. So this one starts at 0, this one starts at 5, this one starts at 10. So it's the difference between where they start. So 5 minus 0 is 5. So this one has a class width of 5. Now every observation must fall into one of those classes. The classes can't overlap. They have to be the same width. And there's no gaps between classes. So when we had bar graphs on the graph, we had gaps. But we don't want any gaps between the classes. All right, so when we're doing these, we choose a class width. We decide why we want it. Choose a lower class limit for the first class. And you want to be slightly less than the minimum. And then compute the lower limit for the next class by adding your class width. And continue with that until you have your class widths set up. So let's look at this one. We already have our classes set up. And so this one has a class width of 1. The width would be 1 because each of them starts one step apart. So when we go through and count up all the values, the frequency of each of these items in their classes, so finding all the numbers that are between 0.00 and 0.99, 1 and 1.99, 2 and 2.99. And you can pause the video and count them. Now here are the actual frequencies for each one. And the total was 65 because there were 65 vehicles. So we also want to find our relative frequency. And remember that was our proportions. Whoops. So we find that relative frequency the same way we did when it was qualitative data. We take our frequency divided by the total. And so we did construct that relative frequency distribution for those car emissions. Now, visually, with quantitative data, what we're constructing are histograms. Histograms are very similar to bar graphs. The difference is that the rectangles, first off, the widths are going to be equal to our class width. And so they're going to be touching. Remember, one of the classes ended at 0.99, the next one started at 1. So they're going to be touching. So we start with where they started at. So our first, I'm going to flip my page over so I have my frequencies here. 0 to 1, 0 to 0.99 actually was 9. So I'm going to go up to 9 and go across to 1. 1 to 1.99 went to 26, so a little bit past 25. and the next class went to 11. Next class went to 13, 3, 1, and 2. Now, if we did the relative frequencies instead, the first one went to 0.138, 0.4, 0.169, 0.2, 0.046, 0.015, 0.031. Now, what do you notice about our frequency histogram and the relative frequency histogram? Well, they look exactly alike. Now, when it comes to choosing the number of classes, if you're setting it up for yourself, you want to be very careful. Notice this is the same data, but there's too many small rectangles. So that's when you have too many classes. Now, if we only had 4 classes, we just only get the basic features. So if you have too few, we really don't get enough detail. But if you have too many classes, it distracts from the pattern. Another thing to be cautious of is it is sometimes necessary for the first class to have no lower limit, or the last class to have no upper limit. What that means is it's an open-ended class. Our example here shows that they're doing the number of deaths due to pneumonia for different age groups. Now notice each of these age groups, our class width is 10, 5 to 15, 15 to 25. But when we get to the last class, it just says 85 and older. Well, that doesn't have a limit. So since the classes must be the same width, this one wouldn't be the same width because 85 and older is bigger than 10. So we couldn't draw that graph. Now, we can also do histograms for discrete data. When the data is discrete, we construct the frequency distribution in which each possible value of the variable is its own class. So notice there's a little bit of a difference on how that one's drawn, but they still have to be touching. The next thing we'll talk about is the shape of a distribution. So from our histograms, we can get the shape of the data. A histogram is considered symmetrical if you split it down the center and have basically mirror images from the right and left. No, hardly any of them are going to be perfect, but this one kind of is symmetrical. This next one has extra data out to the right. It has a right tail. We call that skewed right. Most of the data is clustered right here, but we have these extra pieces out to the right, skewed right. This left one has a tail on the left, so that would be skewed left. So we're looking for the tails of our data. If we look back at some of the graphs we've done already in this section, let me get back to the first page that we had a graph. Which way would this be? Well, it's not balanced, and it kind of has these extras to the right, so this would be considered skewed right. This one would be considered skewed right. Now, we mentioned about modes when we talked about qualitative data, and you can see a mode on the histogram as well. It's the peak or high point. A histogram is unimodal if it only has one peak. if it has more than one peak, and they don't have to be the same height, that is considered bimodal. Next thing we're going to talk about are midpoints. Some graphs used for representing frequency or relative frequencies require class midpoints. The midpoint of a class is the average of its lower class limit and the lower class limit of the next class. So we take lower limit plus the next lower limit and divide by 2. So on this one starts at 0, the next one starts at 1. So we'd add 0 plus 1, divide by 2. Average 1 and 2. Average 2 and 3. Average 3 and 4. And we get the idea. Now I wanted to show, once I had one of these done, how to put these in the calculator. So what we're going to do on the calculator is we are going to go to the statistics app. Let me see if you can see it from this calculator, if I'm going to need to pull up the other one. So I'm going to go to the statistics app, and notice we've got the picture of a histogram right there. And we have value and frequency. I'm going to put my midpoints in. Now notice I couldn't put in a whole class because it doesn't allow me to type in a range. I can, however, type in a single value. And so if it's between 0 and the next one starts at 1, a good value to put in would be the average or the center at 0.5. I'm going to put my frequencies in the frequency column. And notice we have a section that says graph. So if we go to graph, we get several options. We get a histogram. There's a box plot, not to be confused with box graphs. We'll get to that later. We have a histogram, and we have some others that we're going to look at later, but histogram right here. Now that does not put them like we like them. It doesn't have them next to each other because it didn't know we had a full class, but it does tell me the frequency and the relative frequency of each of those groups. So as you go through. And you can actually go in here and change in the settings. If you want to change where it starts and how wide, you could actually put in these starting points and put the class width as 1, and it would make it look right on the calculator. Okay, the next thing we'll talk about is called a frequency polygon. Now, histograms are most frequent to use, but another one that we can do is called a frequency polygon. And for this one, all we do is plot the points that correspond with the midpoint and the frequency. So the midpoint is going to go across here, and the frequency would be up there. So in that table on the previous page, 0.5 went to 9, 1.5 went to 26, 2.5 went to 11, 3.5 goes to 13, 4.5 is 3, 1, and 2. So notice those are at the same heights our histogram would be at. But if we're doing a polygon, all we do is play connect the dots. So if it says polygon, that just means we're connecting dots instead of making the bar graphs. Another type of graph that is used is very similar, but it is called an ogive. I love saying that word. Ogive. Okay, so the ogive is also known as the cumulative frequency graph. So cumulative frequency is kind of like your running total. It's how many we've collected so far. So it's the sum of that class and all previous classes. So this one, there's no previous class, so our cumulative frequency is at 9. When I get to the next class, I'm going to take 26 plus the previous class, so 26 plus 9, and get 35. 11 plus 26 plus 9. 13 plus 11 plus 26 plus 9. So what you can really do is just add your new one each time. Add 11. We went up 13, so I'm going to add 13. We're going up by 3, so add 3. Up by 1. And up by 2. An ogive is constructed by plotting a point for each class. The x-coordinate of the point is the upper class limit, and the y-coordinate is the cumulative frequency. So this is going to be the upper class limit, and we're going to put the dot at the cumulative frequency. So 0.99, we're going to be at 9. Now, the next one would go to 35. 2.99, that class was at 46, 3.99, 59, 62, 63, and 65. And then we connect the dots. Now, on an ogive, you can tell really quickly where you had your biggest gain. We had a really big gain between here and here. I actually like to include 0 to 0.99. That class we had nothing to start with, and by the end of it we had 9. But I can still see this was the biggest jump between 0.99 and 1.99. And that matches that was the biggest jump. We added 26 then. We will be continuing with quantitative graphs tomorrow.